And it's recording, and I'm hoping it will not freeze today, the computer. So I'm gonna share my screen, and so hello everyone, and thank you for coming. And I see there's a strong interest in identifying what we can do with satellite images. And so what I'm showing here is just what we're gonna do today, and it should not take long because it's not, we're not going to go over complex ones, and what it is that it's just a way for us, for the collaborators who want to use the satellite images, just to do enough so that they can do what they need to do for this challenge. The basic approach that I've outlined here is sort of like a good guide in terms of how you want to arrange your notebook or your code. And oh, and let me see if, so I don't know if all of you guys are not familiar with Python. So if you are not, we can go over this later, and I can do another Python course and something like that, just to get started. But it is going to be in Python, and I'm using Google Colab. I saw that there's an access to AWS. I'm gonna look into that and see what I can do with AWS and see what we can do with AWS. But for now, I'm using Colab, and this will be the easiest, I would think, compared to AWS. Uh, so we'll just see. So for the basic approach, typically what it is the first three are, or the first two are just the regular ones that everybody does. You install the required libraries and we load them. And then starting on step 3, I'm going with loading the shapefile. Another thing that you're also gonna notice is there's different methods to these. And so the ones I'm using are the ones that I found that I could easily manipulate further on later. So therefore, if you find yourself that it's different, or you found something else that's better, that's great. And if you think that it's better than my method, please let me know. That would be great. So I'll be loading the shapefile, and I've shown QGIS in the previous sessions, and I'm doing the over there because sometimes you would extract a certain shapefile out of a whole shapefile, and you can look at it at QGIS much faster than loading it in Python. Or even in Earth Engine. You can load it Earth Engine straight away too and do it there. But if you know about the shapefile and you just want to grab it, you can use a different method than I'm showing here, and you just grab that whole shapefile and run it. But here I'm doing it in such a way that I have the shapefiles separated in a form coming from QGIS. So I'm going to skip QGIS here and refer you guys back to the previous sessions. And then the next one, I'll show it later as to what is sort of like something that needs to be done. Maybe the first couple of times once you work with this, but afterwards, when you know what the shapefile is, you can just automatically go through it. And then that relates to step 5 as to how GEE, and I'm using GeoPandas to read the shapefile. And so this particular step is required. And then your standard step 6 that I've seen some people do it, and if you played around with the Earth Engine, that's what step 6 is. And then step 7, I sort of discovered that it's not as easy as I thought to display it in Google, in a notebook in Jupyter environment. So this is one method that I did. So again, if there's something much easier, like 1 or 2 lines, that would be great, because I couldn't find it. So for some reason, I don't know why. So first things first, install the required libraries. So Suzanne and Gitanjali created the environment out of a YAML file. I took that, and for this particular sort of session, I sort of removed all of the advanced machine learning stuff because there were some conflicts. Colab already has something installed, and there were some version issues. So it's not relevant to this, so I took them out. And so I put this in. So based on this list from what they've got, and this is coming from the explicit one, just to be general about it. I removed the PyTorch and TensorFlow, and then I added the AWS. Just it doesn't really do anything, but I just kept it there just to be not to kind of remove everything. So I used this, and that's what you're seeing here. Installing it. So the YAML file, for some reason, I couldn't get it to work here in Colab. So I don't know what I did wrong. So if anyone has a good way of doing it, please let me know. So that's why I resorted to a text form and did the regular pip install rather than do a YAML install. For those of you who don't know, you can connect your Google Colab session with your Google Drive by just clicking here, and then you can just click this part, and then it gives you a confirmation, and then it will link the two together. It does not do it automatically, at least for mine. I don't know if there's a setting that does it automatically. It does not do it automatically, so I have to manually do this. Or today this work, I didn't do it. I just clicked run, and it did it for me. A couple of days ago, it did not. So I don't know what the difference is. But today it worked. And as you can see, a lot of them are already loaded. So, you know, like NumPy and Matplotlib already loaded. It doesn't hurt. You maybe lose a 0.1 of a second to do it. So it installs all of them. And then I just grabbed these two ones from Provin's the code. He gave me permission to use that. So people might be using it, so I just grab it here just to make sure that what I'm showing here is something that you guys can go. So in addition to what Suzanne and G, in addition to this, there's already that, and I think Margot just added another one in GitHub. So you guys can, notebooks, was it task 4? Yeah. So I just grabbed these two just so it's consistent with what they got. And for those of you who have not done this, the reason why Praveen did this is because in Colab and in other Jupyter notebooks that you don't have a permanent account to, you have to do the authentication all the time. And so this does this, and then if you click on it, it gives you this, and then you click on that. And then I did this already, so I'm just, what says, I won't load it in, but I'm just showing it to those who are not familiar. And then you just do a copy on this one. And then there's a bar here, a box here that allows you to paste it in. If you're using a local GUI or local IDE or local Python or the Aconda IDE, or if you have an account, maybe AWS. I haven't tried this in AWS. You don't need to do this every time you use that notebook and log in. And so that's the reason why this is a good approach right here. It allows you to bypass the accept and just go to the try if you're in that situation. So that's what this is. So now, having everything is prepared, then this is where we're gonna start. We're gonna load the shapefile. So the shapefile I put in, this one? So this one. So the shapefile I used, for some reason, Earth Engine is this part of Senegal. And this one has a band, what was it? And it disappeared again. This one is just your standard RGB band, okay? And so this is the shapefile that I extracted for this particular session. And it has like 3 names. So I just called it Medina. And so using the GeoPanda data frame, I loaded into the shapefile, okay? Once you've got this down, and so it's the Medina shapefile, once you've installed it, so all of these 4 files are created out of QGIS when I extracted it from the standard shapefile that we got from gadm.org, loaded in, and then step 4 is the reason why you do this. I don't know if you remember in QGIS when you save it, I showed you that there was that table that had some variable declarations on them. this is where that comes in. It has 14 features, at least for this part, because I extracted the level 2 of the shapefile. It has 14 features, and it has only one row because I'm only extracting that one region. This is gonna matter later when we're gonna start doing processing on all of the area of interest that we're looking at. So this one is gonna start to increase. Depending on the level, if you're gonna go down to level 4 of the shapefile, this might go up, I don't know, maybe 20 plus or something, but it's no biggie. Further down, there's a reason why I chose that particular code to handle this particular number of samples. So coming through here and examining these, you're gonna notice that they broke it down into those number of segments, 1, 2, and then the 3 and the 4. So that means that it grabs the data that's the most level that you've used. So if you loaded level 4 from the shapefile, it will add 3 and 4, but they're a repeat. And the reason why is because this information right here creates the, if you remember when I mentioned the shapefile, it's based off of administrative district levels. So depending on the country, and I just realized that level 2 is called department in Senegal. In other countries might be different. And then I have no idea what this 7.2_1 is. But we know that this is, I guess, a state. Kolda is a state. And so I end up learning some of these when I look at this. And it's kind of great because then I know what I'm dealing with, and I know what it looks like and what it is that they do over there. But for our purposes here, the key here is this last one, the geometry. And so if you remember, I mentioned about vectors and rasters. So in the vector form, it's your standard from learning from math, and if you guys still remember math, the geometry of the vectors, and they call it geometry here in the shapefile. And so here, I'm not gonna go through all of this. You can guess what it is. It's the longitude and the latitude of the points of interest. So if you remember, when I go to the geometry right here, I'll click this box. You know, you've got these points of interest. I mean, I'm sorry, not points of the vector within it. So that's why it's paired out here in an. So this one is in a tuple form. I won't get into the data structure of Python for this one. Just remember that typically they're all good, they're correct. So you don't really need to manipulate these, and you won't get errors on these. If you do then either it was corrupted or there was something that got manipulated there. But for now, just accept it. For those of you who are not into the technical side, just accept it the way it is. Don't be surprised if this polygon word changes on certain shapefiles. It could be multi-polygon, it could be polygon, it could be line. And what that just really means is that if you notice here on the left side here, I click on this rectangular box. In a shapefile, this could be considered a multi-polygon or a polygon. Here, you have draw a shape. Well, it calls it a polygon here. Okay, all right, dismiss. But I don't know if you can see the green color here. So it's called multi-polygon. It could also be polygon. And then you can also see a line or a point. And this is gonna matter in certain situations when you're trying to manipulate the data, the geometry of the shapefile. There are some techniques to do that. I won't get into it right now. When we come to that later in the next few weeks, we'll do it. That's the reason why I sort of have the idea of the jam sessions, because for those who run into that, would be a good way of doing it. But don't be surprised if you just don't see polygon here. However, in the end, it will work out. And the reason for that is because once you do that, and so for our purposes here, all I did was extracted the geometry, okay? You can extract some of these names. And so it's gonna matter when we have many districts and you wanna label them. And labeling them with the name that came with it would be one idea. And so you can just extract the names from it and you know, however you wanna manipulate this. But for our purposes here, I just wanted the geometry. And so now it comes to here where the very first thing when I started doing this, I encountered this problem that Earth Engine wanted it in a particular format, and GeoPandas is a geodata frame. So for some reason, you gotta manually convert them. I believe that here in Earth Engine, yeah, it's doing it again. I believe in Earth Engine, please don't die. In Earth Engine, it does it automatically. Oh my goodness, 17 minutes into it. All right, I'm gonna just speed this up, that way it won't get interrupted. In Earth Engine, under the assets, I believe they manipulate it so that your geometry right here gets converted. But here in Python, you gotta do it manually. And so, you know, so I'm crediting where I got this code. So this is not my code, where I finally found a solution. Now the solution is a little bit different than mine. However, the idea is the same. It's doing a loop, and that's the reason why I chose this, is because it handles multiple shapefiles, and it's gonna come and that's gonna be useful when we handle multiple shapefiles. For our purposes here, we just have one shapefile, so therefore I modified it just to work for one shapefile. Once was it, so you can, you guys can take a look at that and take a look at how that works and all of that. But that's the idea of what this is. Once you get that into what Earth Engine sees, now you can then combine the two, the shapefile determining your geometric shape of that raster that you want to get. And so here I was just testing depending on what the bands I'm getting. Ignore this URL for now. I'm just showing you here that depending on how we're going to, and I have the link here on what I'm trying to do here, depending on what you're trying to get your output, the formats are different for some reason. So that's just something to keep in mind. I know Praveen based his notebook with getting a URL thumbnails, and that's the reason why I showed this, just in case if somebody was curious on how to experiment with this. So for this particular example, I just grabbed so band 5, I believe, was the near infrared. And I was playing around between Landsat 7 and Landsat 8. The reason why I did not use MODIS on this one is because everyone else is using MODIS, so I thought I'd use something else just to have people see what it is. So, these particular information, you can always get them in data sets. And then if you go, so I went to Landsat. And then since Landsat 8 is the recent, started in 2013 into the present, that doesn't mean that you cannot use Landsat 7. There's some technical reasons for the two of them. I won't go over into it for this session. And some of them, expired, like Landsat 5 expired in 2012. So it's up to you. However, it goes all the way to 1984. So if you guys are using Landsat, and depending on the time, depending on what you get, you've got that option. So let me just, since Landsat 8 is new, we're dealing with new things and into the future. And there's a reason why I'm picking on this. It's because it worked for me all the time. The other ones sort of ran into some problems, but this one so far, 100% success rate for me. This is and the reason why I'm showing you is because they give you a minimal standard code to grab the raster. It is in JavaScript. However, I don't know if people have noticed that some of them do not really change much. So this one is no different than what I've got here. So just because it's in JavaScript to Python, if you go to this particular table, so this is in the document section under guides and under the Python installation. It gives you a difference between the JavaScript and the Python. And if you notice, it's for those of you who don't do development, don't worry about this. If you run into some problems in Python and you need some help, you can either get me or somebody else. There's more than myself who knows these, and we can work through this. But the idea here is that you notice there's not much differences. Other than the var and all of that. So if you find yourself going into the reference and if you're going into the API, the client libraries, and let's say we're using the image collection. And that's what we have here, image collection. And you notice, you just click on one, and then you're saying usage, image collection that aggregate count property. Okay, you notice, and then, and this is the one thing about it. In JavaScript, no, your example goes here, so I guess you have to create your own. And in Python, of course, mostly Python has no examples whatsoever. But you notice that and, oh, sorry, I gotta go back. And you're not really changing this part of the equal sign right here. So whenever you see something like that, chances are 90% of the time, if you just use it, it will work. So here, so if you go and grab this, if you just get rid of the bar, 90% of the time or more, it will work. And so you just grab this information and then you just plug it in your Python code and it will work. And so, oh, somebody has something. Yeah. So, hello. So if you grab it, that one, oh, okay, yep, thanks, Susan. If you grab it that way, then it will just be fine. And that's what I did here. I just did this. Bands for satellite, as you can see, the reason why I did it this way is because it gives me a chance to adjust without you doing it. It's just a personal preference. So that's just what it is. If you guys have any questions in terms of my style of coding, you can ask me as to why I'm doing that, and you can tell me that that I'm doing it wrong or I'm doing it like the old days. So so just let me know, and then time range and all. And so these section right here are your standard ones that you've seen out of Google Earth Engine, right here. So essentially, you're just transitioning from it to here. That's basically what it is. And then once you've got that, and once you've done your clipping and your bounding and your geometry and all of that, then it's time to get the output. There are 4 ways to do this. Displaying, of course, here on the notebook. You have the Google Drive. You have the Google Cloud. The assets. I haven't played around with assets much because I've never used them. And then, of course, your local machine. And I think Praveen showed you the local machine, I believe, the download. The cloud, unless you have an account where you have to pay, I ignore them. So I usually either display it here on the notebook, or the easiest one for me is the Google Drive. And that's what Google's encouraging, and that seems to be the easiest and most common. What I've discovered is for local machines and for Jupyter Notebook display, it seems to be difficult. I don't know why, and maybe why I'm having problems of getting that info somewhere, somehow. So I'm using GEE map, and it's GEE map, or I believe I think I put this up in what's this, in the resource page, I think. Hello. And it gives you a utility. It gives you a utility in Python for Earth Engine. And it has a lot of 360 plus, but its particular tools is a lot. It's essentially mirroring Earth Engine's JavaScript. And I think it says right here, because and the reason for that is because, oops, what happened here? These references here, there's a lot. So essentially it's mirroring it. So I've installed this separately from Suzanne's, and this is wrong. Where is it? From the environments. So I've installed it separately because I haven't asked their permission yet to put this in, and I don't know if people will use it. So it's not part of a standard build. So that's why it's done this way. And then I just took out their code, load it, initialized it, and then I did a center of region. So it uses Folium. I don't know. Oh yeah. Okay, you can see it here. It uses the Folium Python utility tool for mapping as its base map. And so if you're having problems in running Folium before, you might have a problem with this. So just keep that in mind. But with Colab, it should, as you can see, it should work. And then get the map base ready. So we've got Senegal here. And then once you've got that, so I got the clip here. So once you've got all of that information, just like you did right here, clip. So just like you did with Earth Engine, okay, when you did your add layer and map and all of that, then you can display it in the notebook, okay? And this is the, you can zoom to it, you can move it. And this is the band 5 shapefile of the region of interest. And then I'm just showing you this one is saving to G drive, and this comes directly from the Python. So if you go to, so Earth Engine JavaScript has machine learning, by the way, if you guys, you know, if anybody would ask, but when we get to this point, we can go over that. But what's it, right here? How come it disappeared? In the API tutorial. Where is it? Oh, image. Somewhere in here has the Python image in them. Okay, I can't find them. I had it here. But anyway, sorry for this. This is directly straight from Earth Engine's what's this code. And I just grabbed it and I ran it and it does work. So hey, it's almost 30 minutes. Great. That's essentially the basics of running Earth Engine into Python. Obviously, you can expand out of this, but just the idea of the fact that you can do this in Python, do your analysis, and so if you're still wondering the differences between Earth Engine, it's just a different platform and a tool. That's all. It allows mostly data science and machine learning are in Python and using Colab or using Jupyter notebooks and all of that. So therefore, people are more used to this and they'd like to do this and continue doing this. So that's the only difference. I've shown you that you can do machine learning here in an Earth Engine. It's not, and as you can see, the preference is TensorFlow. So if you're a PyTorch person, and it's not a lot. So therefore, it's doable. It's I'm not an expert on it. I haven't done a lot of experience with it. I did it once. It's doable and all of that, but I think this is the reason why this exists is because why GEE map exists is because people will do it here. So that is it in a nutshell, in showing you the sort of basics of how to just get running for those of you who have never done this before or just wanted to get some more info. Just get it running, get something out there, and then you've got what you need to look for. And yes. And so having 10 more minutes, anybody has any questions so far or would like to comment or something like that, please do.
So, is it better to do the TensorFlow analysis or like maybe classification and other stuff in QGIS, or like what would you prefer, is Python or doing it in QGIS? Because I think QGIS also has some plugins for the same, right?
Yes, actually QGIS has a built-in Python already terminal in it. At least mine is 3.14. If you guys have the older tools, I think you need to upgrade. But 3.0 and up, it's already built in there. The general answer to your question, and those who are more experienced than I am can interject here, it's a preference. If you're not a TensorFlow person, you want a PyTorch, if you want to use it, then you'd be doing it in QGIS if you can, or definitely in a Jupyter notebook, you can definitely choose whatever algorithm you want to use. The QGIS, it's a tool, it's a software platform, not really built for machine learning. It's for geospatial analysis. So that's why you have a lot of those GUIs and buttons and all of that. Your standard desktop application style. If you're comfortable doing that, please do so. I mean, I'm not somebody who will tell you not to. It's just really a matter of platform and preferences. Having said that, a lot of tools, and when you go search out in by doing a Google search or a Bing, you're gonna find yourself that there's a lot of people preferring the Python side of the world. And along with that Python side of the world, there's this argument between PyTorch and TensorFlow 2.0 and all of that. So different people have a different standing. As long as you're comfortable in one or the other, or whatever other tools you're using, continue doing that, because at the end of the day, you're going to grab what do you call this, an output out of it. And that particular output is, I think, where it matters. Whether you're gonna grab that output and put it in a PDF, grab that output and store it somewhere for your presentation, for your final report, and all of that. That is what matters, because in the end, you want to convince someone, or in our particular challenge, we are trying to present this to our partners so that they can make decisions. So therefore, whatever that you can extract that our final output to the format that you prefer or you're comfortable doing with, that's, I think, the main key thing. Now, we have not discussed as an Omdena challenge group how we're going to present the final output yet. So therefore, at this point in time, you are more than free to do whichever tools you want to use. Okay. So at least this is my personal approach and opinion. Obviously, it's not an Omdena it's not an Omdena rule or something like that. So just bear that in mind.
Okay, thank you.
You're welcome. I'm gonna get rid of this.
Pratyush, one
Yes,
question
yes.
here.
Yes.
At the first day, you told that to make prediction, we require the main data from this map. Like you don't know how we should take the data points from this map. I don't remember the quite terminology from it, but you understand what I'm saying?
You're talking about the information behind the image.
Yes, yes.
Mm-hmm.
So as you said that loading these and downloading these requires time. So is there any way we can directly use the Google Earth engine to download the data from them themselves, like the CSV data?
Can you repeat that again? I'm trying to figure it out exactly. So download the images.
No. Normally what we do, we download the files from Google Earth engine and use it in our Jupyter notebook.
Yes.
But in the first day you told that to make a prediction or to present something, we require the data, the text, the continuous data from
Yes.
the map. Do we have to do all this, or we can directly use the Google Earth engine to do that?
Oh. Yeah. That's okay. So I just wanted to make sure I understand your question. Yeah. So the reason why you can still see my screen, right? Why I'm showing you the machine learning part, because you mentioned what's this Earth Engine doing for you. So in Earth Engine, it has its own JavaScript way. And that's the reason why I'm showing you here, because yes, you can do it to a certain extent. And so you can just, in your own time, when you get to it, you can go through these tutorials, okay? To really manipulate it beyond Earth Engine, this is one method, and this is the only method that I've done so far. I haven't done like the QGIS, way of doing it. I did this tutorial. Didn't really quite have a grasp for it, so I'm partial to this. And just as with the shapefile, so if you notice, the shapefile is being a vector. When you load it with a geodata frame, you've got your familiar features, okay? And you can use your standard Panda style commands. So you get your columns, you get your samples. It will be the same for your rasters. The rasters will have a different structure, but that's how you're going to extract the numbers. So a good way to say that is, I'm using Landsat, and you notice Landsat does not have an NDBI like Modis. But how do you get NDBI out of Landsat? Well, you do the math on the B5 and the B4, and that's numbers. So that's how you get that point. So we're gonna get to that point once we get ready, when everybody has the data, once we prepared and clean the data sets, then we're gonna get into the point. So when we get to that chance, you can you can start now, but we can go through that when we get to that point. Yeah, but that's exactly what you think it is. It will be there. Yeah, that's exactly how it's gonna work.
Okay, great.
Yeah, hopefully that answers that. But if not, maybe next week or in 2 weeks, once we get all the data sets ready to go, then definitely when we start doing the machine learning, yeah, that's how where it's gonna come in.
I think it will require a tutorial to fully understand how we are going to move further from it.
But that one, yeah, okay, no problem. I like doing this because it helps me understand more too, and then it will show what my weaknesses are. So I'm also learning. It's not that I'm trying to show you what I know, but more of on the other hand, the feedback I get and whether I'm understanding this. Because as I mentioned earlier, I'm not an expert on this. This is not my day job. I just like it, so I do this little by little. And this is where I want to go into as a career change, like some of you. And working for NASA, I'd like to do some of the space stuff that they do, but I need to learn a lot more of these. That's why. So anyone else have any questions? We got like about a minute and a half. So
precious of this,
yes.
Sandeep.
Yes.
Yeah, thanks for doing this.
You're welcome.
I noticed that you didn't have to convert any coordinate system from when you import the shapefile and use it with Google Earth. So is that consistent across any type of satellite data inside Google Earth?
There's a standard, and I'm trying to, if I can find it within the minute that I get. There is a standard. I'll go over that later. And that standard is being used by everyone. And so that's the reason why I can do this. But yeah, there is a standard on that one.
Okay, so all satellite data inside Google Earth follows the same.
Yes.
Okay, that's great.
I'm trying to find it. Yeah, so I'll make a note of that one, the standard. Okay. So we got less than a minute left, and what's this? So if you guys have any more questions, just go ahead and tag me or put it out there in the tech help or in satellite image, I guess, or wherever in channels anyway. So that people can help you with your answers and all of that. So that basically it covers for today. I'll have the jam sessions tomorrow, same time, starting same time, but should be short before the general meeting. And that way I have three items I want